Hi everyone, and welcome back to this MATLAB session. Today, in this digital communication lab related experiments, today we are going to analyze the time division multiplexing process and as well as time division demultiplexing process by using MATLAB and some MATLAB code. Okay, before understanding that MATLAB code, so let us try to understand what is the basics of time division multiplexing. So here in this time division multiplexing, the number of input signals which are generally in analog form, first they are converted into sampled signal by using this commutator. So here this is like a switch. So when the switch is connected to any one of the position, then the sample of that corresponding input signal will be transmitted to this channel. Okay, and if this commutator switch is connected to another position, then the sample of the second signal will be transmitted. Then if this connected to another one, then the sample of third signal will be transmitted. Like that, for all the input signals, different samples of the signals are going to be transmitted in a single channel. So that's why it is called as time division multiplexing. Here once again, explaining this simple process of time division multiplexing. Just look at this block diagram. There are number of input sources are there. So by using a multiplexer, whatever may be the multiplexer, that it may be time division or frequency division. So if you are using a multiplexer, the purpose of multiplexer means transmission of the number of multiple input signals or input sources into a single transmission line or a single communication channel. That is the purpose of multiplexing. So number of input signal can be transmitted in a single channel. How they are transmitting in a single channel? How these number of signals can be at a time transmitted to this single channel? On the basis of that is possible on the basis of time sharing, or on the basis of frequency sharing, or on the basis of code sharing. So depending on these three, there will be different multiplexing techniques like time division multiplexing, frequency division multiplexing, code division multiplexing. If these signals are sharing this single channel based on the frequency, then that is called as frequency division multiplexing. Similarly, if these input signals are sharing this common channel based on time, that is known as time division multiplexing. How these input signals are sharing the time and transmitting in a single channel, that is decided by this sampling selector or a commutator which is used in the time division multiplexing process. So this commutator will divide this total time. Let us consider this circle is a total time duration of all the signals, and let us understand this is some t1 and this point is some t2 and next point is t3, t4 and so on up to like this. That means the total time is into different time slots, that is t1, t2, t3, t4, t5 and so on like this. Then how these number of input signals are going to transmit in the single communication channel on the time shared basis, let us see. So when the switch is connected to this position T1, let us say this is T1, then the one sample of the input signal 1 is going to be communication channel by using some modulation technique. So let us keep it as anything, modulation technique is used here. So the first sample of the input signal is going to be transmitted like this. Next, immediately after the second sampling interval, the time t, that this sampling switch is connected to t2. That means the time is changed after t1. After some time, it is changed to t2. So at this particular time instant t2, second signal sample is going to be transmitted in a single channel. Next, again after some time, the switch is changed to T3. Then third sample of the signal, third sample or third sample of the third signal. You can also say that third signal sample is going to be transmitted. Then if the switch is connected to T4, fourth signal sample is transmitted. T5, fifth signal sample is transmitted. Like that, this cycle is going to be rotated like this. For example, let us consider there are let n be 10. Let us consider this 10. So there will be 10 sampling time intervals which are divided based on the total time. So let us take that. Let's assume that T1, T2, T3, T4, T5, and so on up to T10. So for T1, at the instant of T1, first signal sample is transmitted. At the instant of T2, second signal is transmitted. T3, third signal transmitted, and so on. 10 at T10, it is completed. T10, last one. 10th signal sample is transmitted. Like that, all 10 samples of the signals are transmitted as a single frame, as a single frame in a time division multiplexer channel. That means, what is the meaning of single frame? A frame contains all the first samples of the signals, all 10 samples of the 10 signals. Nothing but one frame. Next, what happens? So since one cycle is completed, so during the next cycle of comparator, again T1 is selected. So second sample of the signal is transmitted. Again T2 is selected. So second sample of the second signal is transmitted. T3, T4, and so on up to T10. So during this second rotation, again second frame, that is frame 1 is completed. Frame 2 is transmitted. So in frame 2, all the second samples of the signals are transmitted. Next, in frame 3, all third signal samples are going to be transmitted. Like that, frame by frame, the time division multiplexer signal is going to be transmitted in a single channel. So each frame consists of multiplexed signal of all the 10 input signals. So again, in the demultiplexing process, it will be reversed. So for each and every sampling time from this frame which contains 10 sample signals, so each sample is separated and demultiplexed at each and every output. That is what the exact process of time division multiplexing. So if you observe in our practical way of mobile communication also, since we have only one single tower in your area, so but there are number of mobile phones which are operated continuously at a time. So how they are communicating? How many users can able to share the single channel? So all those multiple users are communicating based on this multiplexing process that is considered as a time division multiplexing. So on the basis of time, at every instant of time, your voice signal is going to be converted into sample signal, and each sample of your voice signal is transmitted at every instant of T1, and second user may be there. The second user samples are going to be transmitted at every time instance of T2. So similarly, third user samples are going to be transmitted at every time instance of T3. So after cycle is completed, again T3 comes. So at that T3 instant, again third user sample is going to be transmitted. So like that, whenever their turn comes, that user is going to transmit that particular sample values. So like that, all the sample values are going to be transmitted at every instant of that particular sampling time. So if you generally observe, there will be some delays because one sample is transmitted of the user 1 at time instant T1. Then to transmit the next sample, the user 1 has to wait until this completion of this rotation. Again, when T1 comes, second sample will be transmitted. So if you generally observe, there will be some delay. So with this, this person need to wait until this rotation, until completion of this all times. But if you observe practically, that time values are generally in microseconds, maybe in picoseconds also. That is stand for -6 seconds. So that value is very, very less that user cannot able to observe that change, observe that delay. That's why continuously our voice signal is going to be transmitted in a single channel with a multiplexing process. So that is what the concept of multiplexing. Now in this lab session, by using MATLAB, we are going to observe how the multiplexing signal is obtained at this output of the multiplexer, or output of the time division multiplexer, and how the demultiplexing process is. Using signal here, the time division multiplexing is generally used in digital communication only, because in analog communication we cannot sample the signals. But here we must do the sampling. Then only based on the samples only we can able to multiplex. That means in time division multiplexing, we should be able to observe that first sample, then only based on the sample signals only we can able to apply multiplexing process or time division multiplexing. Clear? Now let us observe the MATLAB code here. So here, this is the MATLAB code for time division multiplexing for 2 signals, and this is the MATLAB code which is modified only based on this, corresponding to 4 signals. So in the first case, let us consider 2 signals here like this. Let us consider 2 signals only. How these 2 signals are multiplexed. Now, so this is the general things, clearing all the values here. After that, one signal is generated as a sinusoidal signal, and for this sinusoidal signal, x limit, that is time axis, is represented from 0 to 4 pi. This is the minimum value is 0 and maximum value is 4 pi. That's the sinusoidal waveform having the intervals of 0 to 2 pi. Here I am taking double value. So 0 to 4 pi is the range of the time axis of the sinusoidal signal, and the range is varied in the interval of 0.5. So this is the general representation of time axis of any sinusoidal or analog signal. Now, here next, the sinusoidal signal, signal 1. Let us take that signal 1 as sinusoidal signal, signal 2 as the triangular signal. So signal 1 is equal to 8 into sin x. This is general formula for any sinusoidal signal. Let us take that is x1 of t is equal to 8 into sin 2 pi of ct, or to sin 2 pi of t. Let us take that. So here signal 1 is equal to 8 into sin x, that is 8 is the amplitude value, and L is the length of the signal 1. So let us consider the length of this sinusoidal signal is equal to L, which is stored in a variable, that is L. Okay. So length in the sense number of time axis or number of values on the x-axis. Next, signal 2 is considered a triangular wave, and the amplitude again taken as same, that is 8 into triangular of L. So this function triangle from length will give you the triangular waveform within that length of the signal. Here length of the input signal and this signal is also same. So within the same length we can able to obtain the triangular wave. So here I am directly displaying both the signals in a single window. If you want to display this in a single window, so let us take that subplot of 2, 2, 1, and why I am taking 2, 2. Whenever there is a subplot which contains 2, 2 means it is having 2 by 2 matrix, that is 4 elements are there, 2 elements in first row, 2 elements in second. So that means I am going to display 4 signals. First signal is sinusoidal signal, second one is triangular signal in a analog form, and next 2 signals are the sampled signals of these. Next 2 signals are the sampled signals. Before going to observe, and let us observe only these 2 signals first, and commenting this and try to produce these waveforms. Now if you observe this, these are the 2 signals. Sinusoidal signal is displayed having an amplitude of 8 and -8, and this is the triangular wave which is displayed in the same length. In the same length it is displayed. Now again I'm commenting this. Now let us see how the sampled signal is displayed. Generally, we know that sampled signal is displayed just by using a function called stem. Whenever if you plot the signal by using stem function, automatically the sampled signal is displayed. This is only the simple notation. So let us take the third signal will be sampled signal of sinusoidal, and fourth signal will be sampled signal of triangular waves. So in this 2 by 2 matrix, the third element is display of sampled sinusoidal signal having some x-axis time, y-axis amplitude. All these things are the same for all the waveform, title, x label, y label. So in the fourth element of this window, sampled triangular wave signal is displayed. Okay. Now up to now, what will happen? Let us see. I'm displaying this at this point. Now you can clearly observe. This is what the sinusoidal signal. This is the triangular signal. And here I am taking two signals as to multiplex. So before multiplexing, we must convert the signals into sampled signals. So that's why I am converting the sinusoidal signal to sampled signal. Similarly, the triangle signal also into sample version. Then only these sample signals are going to be multiplexed. Now again I am removing this and commenting this. Now again observe. So we have displayed both the input signal as well as the sample signal of this. Now let us consider L1, L2 are the length of the two signals. So here, in order to display the time division multiplexed signal, here what we need to do is, let us observe this. For example, let us assume that the signals as S1, S2, S3 and so on. So each signal value is already converted into sample. So that means each signal is having some number of finite number of sample values. So all those sample values are generally stored as a row vector like this. So all these are nothing but sample values of signal 1. Similarly, all the sample values are stored in a row vector as signal 2 and signal 3 and so on like this. So in order to convert these three sampled values or signals into time division multiplex waveform, then we need to convert these row vectors into a matrix. So how it is converted? So all the elements in this row vector is converted into one row in this particular matrix. So S1 elements are first row, S2 elements are in second row, S3 elements are in third row. Like that, this all row vectors is converted into matrix form. Then only based on this matrix only we can able to display the time division multiplexing waveform. Similarly, for demultiplexing process, again we need to reverse this matrix into each individual row vectors. So to display this row vector directly, we can able to obtain the demultiplexing waveform. Right? So this is what the process we are going to use in this code. Now let us observe this. Let us observe this. So here I am taking one for loop starting from 1 to length of the first signal, because length of L1 and L2 both are same. We have already taken, because triangular wavelength and sine wavelength both are same. But let me take L1 and L2 are the length of the signal 1 and signal 2. So for this entire length I am applying for loop, so that signal Sig of 1 comma I, which represents here, this process is nothing but making these row vectors into a matrix. So the matrix size is represented by these elements. 1 comma I represents first row. In that, all elements are nothing but signal 1 elements. Next, second row. In the second row, all elements are nothing but second signal elements. So that finally, this variable contains all the row values of the two signals. So it is directly converted into a matrix form. So Sig variable contains the as a matrix. Now, so time division multiplexing of this both the signals is obtained by using a function called reshape. So this reshape function will produce the matrix form. Okay. For example, if you want to observe what is the meaning of reshape, so you can type help reshape, so that you can clearly observe what is the meaning of reshape function. So it is a reshape function of x comma m comma n will give you the n by n matrix whose elements are taken column wise from x, or reshape of x comma m comma 1, whatever may be the elements after x, then it will return a matrix or array with the size of these all multiplications. So here this reshape will produce the signal as a matrix or array with size of this 1 comma 2 into L1, because we have two elements are there, two signals are there, we need to multiply the length of the signal as 2 times, because as we know that when two signals are multiplexed, then what is the length of the multiplexer signals? So that is equal to 2 times of the each length. If 3 signals are multiplexed, then what is the length of the multiplexer signal is? That is 3 times of each length. So that's why we need to take like that. And since we need to display this time division multiplex waveform as a single waveform, that's why the size is represented as 1, 2 into that length. Okay. For example, if this length is maybe 10 units, so then 1, 2 into 10, that is 1, 20 is the size of the array, which is reshaped as a signal. So it will display the array having the elements with the size of 1, 20. That is an example. So this array is going to be displayed as a waveform because we need to have a waveform of time division multiplex waveform. Because after sampling only the multiplexing is done. So here also we need to display the sampled version of multiplexer signal. That's why here I am taking again stem of this TDM signal after reshaping. Then if you display this directly, you can clearly observe the time division multiplexer waveform. For example, here I am commenting this remaining part and I am going to observe the output. Then if you clearly observe, this is what the input signals and the multiplexer sample version of the input signal. So in the second window, you can clearly observe this is what the multiplexing of two signals. For example, we clearly observe these amplitude values. This is what the sine wave and corresponding sampled version of the sine wave. And this is what the triangular wave and the sample version of the triangular. So both the sampled version of sine wave and triangular wave both are multiplexed here. Both are multiplexed here as a single waveform containing some number of samples. So if you can clearly observe how the multiplexing is done carefully, then if these are the samples of the sinusoidal signal, then between these samples, the triangular wave samples are going to be displayed. So that means this total time is going to be shared by this both sinusoidal signal and triangular wave signal. So like that, if you are going to add the third signal, then between these two samples, the third signal sample value is going to be multiplexed and then transmitted in a single channel. Okay. So clearly observe between each sinusoidal samples there will be one triangular sample. Clear? Between each sine wave sample there will be one triangular sample. Like that, these two signals are going to be multiplexed. This is very clear understanding. You must be able to know how these sampled signals are multiplexed. Okay. For example, 10 signals are going to be multiplexed. Then this time, this gap is going to be shared by remaining 9 signals. That means remaining 9 samples are going to be displayed between these two samples. That's how the time is shared, and then number of signals are going to be multiplexed here. Now, let us observe the demultiplexing process also. Demultiplexing process, again we already said that here we convert the row vectors into matrix. Again we need to recover back, so matrix must be converted into row vectors. So the same for loop is used. Okay. So again after reshaping into demultiplexing variable, so I'm changing this time division multiplexer signal into again reshaped into matrix form having the elements 2, L1, which is the size. So again I'm converting this matrix into again row vectors. So converting the matrix into row vectors. So this is the matrix. This is the matrix size. So each matrix first row is converted into one signal, and second row is converted into another signal as a row vector. So these are the row vectors after converting into vectors. So these are the two different row vectors. These two different row vectors are named as signal 3 and signal 4. That is nothing but demultiplexer signals. So directly I am displaying these two signals after demultiplexing. Then these signals must be original signals, not a sample signal. So that's why I am using this plot function again. Plot of signal 3 will give the recovered sinusoidal signal. plot of signal curve will give the recovered triangular signal. So these two signals are plotted in a single window. That's why a subplot of 2, 1 size is taken. So if you display these two directly, then what will be the outputs here? Now carefully observe. This is what the input signal. Two signals are going to be multiplexed. So before multiplexing, these two signals are going to be sampled. After sampling, both the signals are going to be multiplexed as a single signal. This is what the multiplexed signal on the basis of time share. And finally, this is what the demultiplexed or recovered sinusoidal signal and recovered triangular signal. You clearly observe both the wave shapes are same. Similarly, the amplitudes are also same, 8 volts and 8 volts. Clear? So this is the time division multiplexing and demultiplexing process, which is in a more detailed way. Similarly, if you want to observe four signals, how four signals are multiplexed. In this case, here I am taking all the four signals as a sinusoidal signals only. Okay, don't worry about this code because only this code is extended up to four signals. That means whenever two signals are there, that code must be repeated again 2 times. Okay, for example, in initial case, signal 1, signal 2 are there, but here signal 3, signal 4 also there. So all the signals are I am taking as sinusoidal signal, but having different amplitudes. First signal amplitude is 8 volts, 6 volts, 4 volts, 2 volts. Okay, so all the signal voltages are having different amplitudes I am taking in order to differentiate the signals. Similarly, I am displaying the four signals in a single window, and similarly, all the sampled signals are also displayed for all the four signals. After sampling, I am going to multiplex. So before multiplexing, we must convert all these signals from vectors into a single matrix. So based on that matrix, we need to reshape that into a single waveform. So display that waveform as a TDM signal. And again, demultiplexing purpose, again we need to recover this matrix into single vectors. Each vector contains the demultiplexer signal. So display the demultiplexer signal directly. So if you observe this, I have taken four different sinusoidal signals. All those are sinusoidal signals only having different amplitudes. For example, this is having 8 volts, this is having 6 volts, this is having 4 volts, this is having 2 volts. So different amplitudes are I have taken, and these are the corresponding sample signals. Next, what is the multiplexer waveform for this? This is what the multiplexer waveform. So you need to carefully observe what are the four signals here. For example, the first signal is having the amplitude of 2 volts. So this is what the samples of 2 volt sinusoidal signal, the corresponding samples here. Next signal is 4 volt sample sinusoidal signal. This is what? Next, 6 volts amplitude sinusoidal signal, and 8 volts amplitude. Finally, 8 volts amplitude sinusoidal. All these four signals are multiplexed and combined as a single signal. So if we carefully observe, this is the first one sample of 8 volts sinusoidal signal. This is the another sample of 8 volts of sinusoidal signal. I have already said that multiplexing is done based on the time shared basis. So between these two samples, this total time is divided into 4 parts. In each part, one sample is transmitted. For example, between these two samples of 8 volt sinusoidal signal, the remaining 3 samples of the 3 signals are going to be multiplexed here, transmitted here. So this is the one sample of 2 volt signal, this is one sample of 4 volt signal, this is one sample of 6 volt signal. Like that, this gap or time is going to be shared among these different signals, so that they are multiplexed and transmitted in a single channel as a single signal. On the whole, if you observe this kind of signal, it looks like a single signal having some number of samples, both in amplitude, in positive and negative durations. Okay, this is the process of multiplex. Similarly, if you observe the demultiplexing, all those 4 signals are going to be demultiplexed again as the original sine waves, like this. So recovered signal 1, 2, 3, 4, and so on. And if you observe, the amplitude is also same, 8 volts, 6 volts, 4 volts, and 2 volts. So this is the MATLAB code and the corresponding explanation and representation of multiplexing and demultiplexing waveforms. Okay, so thank you all to listen to this class. So that's it for the class. So thank you very much.